I divide everything through by 4 to get rid of the 4x squared. I can't because I have a 9 in front of the y squared. So this is going to be an ellipse. And remember the general form for the ellipse, I need to have the 1 on the right-hand side and then my completed squares. So I'm going to start by rearranging the equation. So I'm going to have 4x squared first minus 48x, leave some space, 9y squared plus 72y, leave some space, and then I'm going to move the 144 to the other side by subtracting it to the other side. You got to be really careful with copying the question, correctly and not missing a minus sign or plus sign. So then your next step is on this first trinomial, I need to factor out that 4 so that I can complete the square. So I would have a 4x squared minus 12x, and I'm going to complete the square inside this trinomial. So I divided by 4, it's sitting out here. Now to complete the square, the formula is you take half of the b term and square the answer. So negative 6 squared is positive 36. Positive 36 got added inside a parenthesis though. So how much do I actually have to add to the other side? I have to add 4 times 36 to the other side. So you take 4 times 36 on your calculator. What do you get? Or maybe do it in your head. 36 times 2 is 72 times 2. You're actually adding 144 to the other side. 4 times 36 is 144. Now I do that whole thing again with the y part of this problem. So I'll have plus 9 parentheses y squared plus 8y, right? Because 72 divided by 9 is 8. What do I add inside this parenthesis? So I cut the 8 in half, 4, and then 4 squared is 16. So I'm adding 16 in the parenthesis, but I need to add 9 times 16 to the other side. All right, so that's a nice perfect square. So I'm going to add 144 again. So a lot of algebraic steps. Use your calculator if some of these numbers are too big. So now I'm going to go through and actually factor these trinomials that should have come out as perfect squares. So I've got 4, and then this would be x minus 6 squared, right? X minus 6 times x minus 6. X minus 6 squared. What does the y trinomial factor into? It would be y plus 4 times y plus 4 to get the 16. Y plus 4 squared. And I ended up with a total of 144 on the right? Because these added up to 0, 144. So your last step is to get a 1 on the right-hand side of the equation. So you kind of divide through backwards. And then to find what your new denominators are, we're just going to take 144 and divide by 4, right? Divide by 4 on top and bottom. And 144 divided by 4 is 36. So we end up with x minus 6 squared over 36. Then I'm going to take 144 and divide by 9 to see what I would end up with in the denominator. So that gives me 16. So I have y plus 4 squared over 16 equals 1. So that's a lot of algebra. So if you want me to check your algebra before you go and try to graph the ellipse, it would be good to make sure that this equation is correct before you go and graph everything. So this is a lot of algebra, and I'm only going to ask you one of this type of question on a quiz or a test. Most of the equations I'll give you will be in this format, so you can just graph them and solve them. All right, so where's my center? Positive 6, so it's right 6, and it's down 4. This y plus 4 would go down 4. So I'm going to plot my center at 6, negative 4. So then once I have the center, I need to decide, is my ellipse horizontal or vertical? And the bigger number is under x. So it's going to be a long horizontal ellipse. And I like to write that a squared is 36 and b squared is 16, so I can see right in the problem. This is a squared, this is b squared. So I know that a is just 6. I take the square root of 36. And b is just 4. I take the square root of 16. So from my center, did I make this not fit? In the A direction, so the horizontal direction, I'm going 6. So you'll just have to go off the graph a little bit, because you have to go 1, 2, 3, 4, 5, 6 in each direction. So it would be over there at 12. And then you're going to go up and down 4. So 1, 2, 3, 4, 1, 2, 3, 4. So here's my ellipse. Good job going through there. All right, so then the last piece that we need to plot on our graph to finish this problem is where our foci are located. So those are going to be somewhere on this major axis. And we're going to do a squared equals b squared plus c squared. So that's that Pythagorean identity. We kind of proved it last time, but if you didn't really understand the proof, that's okay. It's just the relationship between a, b, and c. So we're going to plug in the information we know. 36 equals 16 plus c squared, right? Because this is a squared and this is b squared. So then subtract 16. C squared has to be 20. So what's the square root of 20? 4.5 about. So C is about 4.5 units. So that puts my foci 4.5 units on the major axis. 1, 2, 3, 4, away from the center. So we're going to learn how this C value later in class affects the eccentricity, how elongated that ellipse is. So that's a lot. That just took me 8 minutes to do one problem, right? So it's going to take you a little bit to work through these couple problems. Try the algebra. If you need some help with the algebra, make sure I check your equation before you just start graphing all the things. But see if you can do it. The answers to 2 and 3, if you want to use them, will be on the video. So you can pause it and take a look at it later, or I can give you some help later. Or you could come back to this in a minute. How about that? But I want to take a look at, some of you already tried these, but if you're given clues about your equation, this is going to really show, like, hey, can you put an equation together? Do you know how the pieces of the equation are working together? So you've been given clues, and you need to write the entire equation of the ellipse. Now, when the center's at 0, 0, you have almost your whole equation written for you, right? Because you're not going left or right, you're not going up or down. So you can just write out x squared plus y squared equals 1, because you know that an ellipse is in that format. So now you just need to figure out the denominator for x and the denominator for y using your a and b values. So that's a little bit more challenging. So let's think about, what direction is this ellipse oriented? Is it a horizontal or vertical ellipse? So if I think about starting at 0, 0 for my center, it tells me that one of my focal points is at 3, 0. And that tells me a lot of information. So if that's a focus, I now know the ellipse goes horizontally, right? Because a focus is always on the major axis. All right, I also know something else. I know the C value for this ellipse, right? The C value is 3, because C is the distance from the center to a focal point. And I also know that a squared goes under the x. So that was a lot of information from that one point. The other clue they tell me is that the major axis, which I already know goes in this direction, has a total length of 10. So that means I have to walk 5 in this direction and 5 in this direction, and that's my total length of 10. So I just figured out my A value from this, right? A would have to be 5, because 5 plus 5 would give me the total length of 10. So now I know my A squared value. My A squared value is 25 to make this true. So you have to know some vocabulary, major axis, how to figure out your A value. So the last piece I need is my B squared value. How can I figure that out? Why is it 16 though? What formula did you just use? So you used the Pythagorean identity for an ellipse, and you plugged in 25. We don't know B squared, but we know C is 3, so C squared is 9. So you recognize that that was it's called a Pythagorean triple, but you could do this out if you don't recognize that. Subtract 9, 16, right? And I really do want B squared, right? Because B squared is what I need for my equation. So B is 4, but I really care that B squared is 16. So to me, these are challenging, and you want to graph it out. So I'm going to do these with you. If you want to try them on your own, there's some of these in the book for the homework, but there's some of this is vocabulary that you might not know. So on example 4, there's a word here that says semi-minor. So I'm afraid you might not know what that means, but center is again at 0, 0. So I'm going to just frame out my equation. I know x squared plus y squared equals 1 is the framework of my ellipse. I don't have to go left or right or up or down. So it tells me one of my vertices is at 0, negative 3. I'm not really sure if it's major or minor axis, but I know that at 0, negative 3, I have a vertex. So I also know that at 0, 3, I must also have a vertex, right? Because ellipses are symmetrical with itself. All right, semi-minor means half of the minor axis has a length of 2. If it's half the minor axis, isn't that B, right? Because 2B goes all the way across the minor axis. So 2 is B. So that tells me that this is my major axis, doesn't it? Because this value is 3. So that tells me that in this direction, right, I would go 2 and 2. So that half of my minor axis has a length of 2. So where do I put my values now? So in the x direction, how far did I walk? I walked 2 units. So I'm going to square that and put 4. And in the y direction, I walked 3 units. So I'm going to square that and put 9, right? Because this is b squared in the equation, and this is a squared in the equation. Does that kind of make sense? It's a lot of clues that you've got to put together carefully. All right, example 5, I'm going to have you try to write the equation, but I want to tell you what tangent means. So tangent means that it just touches it at one point, and you can kind of use the center as you write your equation. But if I'm at 3, 5, tangent means I just touch the axis at one point and I don't pass through it. So it's tangent to both axes. So it touches that point, but it doesn't pass through it. It just touches it and bounces off, and it touches that point. So see if you can use that information to correctly write using the center and figure out your A and B values from that. I'll give you just a couple minutes to try that equation. And then we're going to talk briefly about eccentricity, if this makes sense. My center went right 3 and up 5. So right 3 and up 5, x minus 3 squared plus y minus 5 squared equals 1. And then the denominator of x is 3, because I went 3 units in this direction, and the denominator of the y is 5, because I walked up 5 units in this direction. Does that look like what you got, or it kind of makes sense what you got? So anyway, I think there's one or two of those where you have to kind of problem solve on the homework tonight. So you should have already done 4-1. So you only are focusing on 4-2 for tonight on the ellipses. All right. So I wanted to also look at eccentricity today.